we will learn an equation of stationary wave. Equation of stationary wave on a stretched string. Equation of a stationary wave on a stretched string. Okay. Here we will consider any progressive wave. यहाँ पे हम क्या करेंगे, एक प्रोग्रेसिव वेव कंसिडर करेंगे. Okay, this is a xy axis. This is a y axis and this is a x axis. और यहाँ पे हम क्या करेंगे, एक वेव कंसिडर करेंगे. Here we will consider a wave which is progressive wave. This wave is starting from point O or 0, and here this is going like this. This wave is going in a forward direction of x axis. This is a x axis and this is a positive direction of x axis. This is the positive direction of x axis. Therefore this wave is going in a forward direction of x axis. Okay. Therefore the equation of wave traveling along the x axis in the positive direction is given as. तो हम क्या करेंगे, एक इक्वेशन लिखेंगे. This is the wave having this is a positive amplitude A, and this is the negative amplitude minus A. This is a plus A and at lower side there is a minus A. Okay, therefore this is a positive amplitude and this is the negative amplitude, and therefore we know that the equation of wave traveling along the x-axis in a positive direction is given by y. Let us consider this is a wave y1 is traveling along the positive direction of x-axis. Therefore this is given by a sin omega t, a sin omega t minus 2 pi x upon lambda. 2 pi x upon lambda. We have learned this wave in previous equations कि ये वेव कैसे आती है. y1 equals to a sin omega t minus 2 pi x upon lambda. This is the angle omega t. But we know that omega equals to
2 pi upon s
pi into n.
sorry.
Therefore this y1 equals to a sin 2 pi n into t. 2 pi n into t minus
2
pi
x upon
x upon
lambda.
Okay, therefore we can take 2 pi as common. Therefore this wave will be equals to y1 equals to a sin 2 pi
upon nt
into nt minus
x upon lambda.
lambda. Therefore this is equation 1. This is equation of a progressive wave forwarding in a positive x direction, moving in a positive x direction. Okay, here this negative sign is showing that this negative sign along the x axis shows that the this wave having the displacement y1 is moving positive x direction. पॉजिटिव एक्स डायरेक्शन मीन्स ये वेव क्या हो रही है, यहाँ से जो वेव है ये डायरेक्शन कौन सी है इस वेव की, पॉजिटिव एक्स एक्सिस, पॉजिटिव एक्स एक्सिस. Therefore this negative sign, always remember that when there is a negative sign, this means that wave is going in this direction along the positive x direction. Okay, now here we will consider another wave y2, and in that y2 we have to consider the wave which is traveling in the opposite direction of x-axis or negative direction of x-axis. Here y2 is, we will consider any wave. Here another wave y2, or here we will consider let a progressive wave. We will consider a progressive wave which is moving, moving in negative direction of x-axis. Negative direction of x-axis. This means in this direction. Okay. Therefore, as we know that the wave which is moving in a positive direction of x-axis have a sign negative here. Therefore, if we consider the wave which is traveling along the negative direction of x-axis, means opposite to this one, then we need to take a positive sign here.
म्हणजे x axis च्या दिशेने पण निगेटिव्ह साइडने चालली.
Therefore, y2 equals to a, amplitude is same, sin 2 pi in bracket nt plus x upon lambda
bracket
close. This is equation 2. This is equation 2. This equation shows that the wave is moving in a negative direction of x-axis. We know that what is the direction of x is this is the direction of x. This is the x direction of x. Okay, direction of wave. This is the direction of propagation of wave. Direction of propagation of wave. Okay, but this is a positive direction. This is a positive direction. But when wave is coming this opposite direction, means sometime this wave also can come along the negative direction of x-axis. Therefore, y2 equals to a sin 2 pi in bracket nt plus x by lambda, equation 2. Okay, equation 2. Therefore, we will consider the superposition of two waves. Now, the superposition of two waves. In that superposition of two waves, the resultant wave y will be equal to the vector sum of two waves y1 and y2. Here we will consider the magnitude of two waves. Therefore, we have to add equation 1 and 2. Now, therefore, we will add equation 1 and 2 in order to get a y. What is equation 1? A. What is equation 1? A sin 2 pi nt x minus lambda in bracket. A sin
2 pi n into t
minus
x upon lambda.
X upon
lambda.
X upon lambda plus a sin 2 pi
n into t
plus, this is plus x upon
lambda.
Okay, Therefore, we will consider, we have the equation, but we have sine C plus sine D. What is sine C plus sine D?
Sir, 2 sine.
formula sir.
There is a formula for sine C plus sine D.
Trigonometric formula.
This is the trigonometric formula. Will be equals to 2 times
Sine
sine
C plus
C plus D by
upon 2
2 into
cos
cos into multiplication into cos C minus D upon
2
2
bracket 2.
bracket close. Therefore here we will consider this is a C and this is a D. Therefore here y equals to, we will consider A is a common in both cases. Therefore here we will consider A in bracket sine 2 pi, sum of this bracket C and D, nt minus x by
Lambda
lambda plus nt plus x by lambda divided by
2
into cos nt minus x by lambda minus of minus of minus, what is D? This is a D, nt plus x by lambda. Okay,
x by lambda
nt
x by lambda
plus
plus
x by
11 lambda
lambda bracket close divided by
2
Okay, now here this x by lambda and this x by lambda get cancelled, and here
anti cancel नहीं हो सकता
2 times plus sign is there. Therefore this will be equals to A equals to, here y equals to A in bracket this 2 and this 2 get cancelled, plus 2 pi, this 2 and this 2 get cancelled. Therefore sine, what will be remain here? Nt,
anti
and pi will be there. Pi will be there. Okay, but here nt plus nt is the 2 times of nt into cos 2 pi into cos 2 pi in bracket is nt minus x by lambda. Here this 2 and 2 we have cancelled, this 2. Okay, minus nt, because this minus sign go inside the bracket, and this minus and will be this minus x upon lambda. What will be cancelled here? This nt cancel with this nt. Okay, what will be remaining? Minus 2 times x by lambda, minus x by lambda minus x by lambda. Therefore this will be 2 times x by lambda. Therefore this will be equals to A in bracket sine 2 nt into, this is angle 2 nt into cos therefore this will be sine pi 2 n t
2 anti
cos
pi
pi minus 2 times x by lambda, x by lambda bracket complete. Okay, therefore the y value of y will be this, a sine 2 pi nt, but we know that but cos minus theta equals to cos theta.
theta.
Therefore this minus will be considered as a positive. Therefore y equals to a sine 2 pi n t, this is angle, into cos 2 pi x upon lambda, 2 pi x upon
Lambda.
lambda. Okay, therefore if we take a here, cos 2 pi x upon lambda into sine 2 pi n t, sine 2 pi n t. Let capital A equals to a sine we will consider this complete term as a cos 2 pi x upon
Lambda.
lambda, 2 pi x upon lambda. ठीक है, therefore this y will be equals to a sine 2 pi n t, 2 pi n t. Okay, 2 pi n t. Again 2 pi n is a omega. Y equals to a sine omega t, since omega equals to 2 pi n.
2 pi. 2 pi.
Omega equals to 2 pi.
2 pi.
This is equation 3. This is the equation for stationary wave. This is the equation for stationary wave.
view.
This is the equation for stationary wave. Equation of stationary wave. In that equation, there is no term x and lambda. You can observe. यहाँ पे देखा गया तो यहाँ पे इस इक्वेशन में x भी नहीं है और लैम्बडा भी नहीं है. There is no x and lambda in this equation. Therefore, we can say that as there is no x and lambda in this equation, therefore this wave is independent on x and lambda. What is x? X is the distance from the point
zero
O to any forward direction. म्हणजे this x is at any distance. This distance x, this may be any distance. But there is no x and lambda in the equation. As there is no x and lambda in this equation, therefore we can say this wave is a steady wave. This wave is the steady
Steady
wave.
wave.
Therefore, as there is no x and lambda, there is no x and lambda in the equation 3. There is no x or lambda in the equation 3. This means that wave is independent. Wave is
Independent.
on x or lambda. Q is independent on x or lambda. Okay, this is therefore this wave is a therefore this wave of equation 3 is stationary wave, is a
Stationary wave.
stationary wave. Okay, so this is a stationary wave.